2012 years of Primary 6 from Sipa Primary School. Welcome back to another lesson for physical chemistry. For this lesson, we'll be revising for the Boltzmann and the Maxwell-Boltzmann distribution. So for this part over here, for this lesson, we'll be mainly revising for diffusion and effusion. So we'll be comparing the difference between diffusion and effusion while explaining about what they are. So over here, for diffusion and effusion, what are their definitions? So over here, definition, it's basically like how you solve it, and also definition, and over here is the process of expanding the process of the expansion of Okay, so the definition of diffusion is the process of expansion of gas through a barrier with holes. So what I say about this is that over here, actually for this part, it can, no matter how many holes or how big the holes are, it doesn't matter. So even if there is basically no barrier or anything, it's just the process of the expansion of gas. The gas has been distributed. So over here, let's continue with effusion, and later I'll compare the two. So instead of through a barrier with holes, the definition of effusion is the process of so the similarity between diffusion and effusion, both of them are going to relate about the process of the expansion of gas, but the difference is that how it happens. So over here, similarity, both are about expansion of gas, but over here for effusion, through okay, never mind. I'm just going to write. A container with small holes. So over here, when I say for this, it is different from diffusion because the holes, it must be small, and later I'll talk about the difference of size of the holes. But over here for effusion, the number of holes is like, okay, you can have more than one holes, it's fine, but the holes cannot be, you cannot have too many holes, and the holes cannot be too big. So I'm going to explain it at the meaning. So let me just tell the difference between definition and meaning. So for definition, although normally speaking, we are practically using definition and meaning similarly here, but over here definition, we're talking about the process and how we do it. But meaning is basically what it's for and all, okay? So over here, diffusion, it is as you can see for this part, for diffusion, it's like, as I told you before, it doesn't matter how big the holes are. So when the gas travels from a place with higher concentration. So over here, the concentration that we're talking about, it can be anything, okay? Give me a sec. So it travels from a place with higher concentration to a place with lower concentration. So over here, what they're saying is that it's like, if you smell flowers, flowers have fragrance, right? Or anything. A lot of things have fragrance, like food and all. Also, diffusion is like, this one place has more of the smell and all, basically with higher concentration to like somewhere else, like another room, like when you're cooking in the kitchen, and you may have like the fragrance is much stronger there compared to when you're in the living room. Well, how diffusion is that the fragrance will basically travel to the living room. Okay, so it's basically gas mixing. It's basically gas mixing together. Okay, it doesn't matter if there's holes or barriers. It's like, as long as it's like, anywhere. It can happen anywhere. It's like even when you're cutting grass and all, you may have some sort of smell. And diffusion will definitely happen, and the gases will mix together. Meanwhile, for diffusion, gas will have to escape from the container through the tiny holes. So over here, the condition is basically the fact that the gas can travel through the hole. So over here, if you're going to compare, I forgot the word gas. So if you're going to say what this can do, is basically the gas can travel through the hole. And here is that the gas can mix with the gas can mix together with other gases, can mix. If you just want to write it shorter, so over here I'm going to draw a diagram. So it is basically saying, so for diffusion, I'm going to draw here. It's like okay, so it doesn't matter if there is holes or not, so I'm not gonna draw the holes. So over here for this side, it's like, if there's more of this, like, the molecules, there's more over here, and then there's like lesser and lesser over here. The gas will basically travel from this more, so this part is the more concentrated area, the density is higher. For this, gas, then after that so it will always move away from the gradient, the one with the higher gradient, and to the one that has lower concentration. But one thing that I need to tell you is that they don't just spread out evenly. That's one thing that you must take note. Is that they move together. They just move they travel to the place with lower concentration at random, because they'll just they can like what you call it, crash together like anywhere. It will definitely travel to the place with lower concentration, but the direction you can't confirm it, because it just travels to the place with lower concentration at random. Okay. Well, over here for this part, the difference is that, so even if it's still like this, it's like there's only a small hole, so you may not be able to see it, so I'm just going to make it bigger a bit. Yeah, like this. So it's basically through pressure over here, her particles from this part will come out, okay? But the direction they come out, it's also not definite. It's like, even though the hole may be like this, that doesn't mean that the direction will only escape through here. It just escapes like this, okay? Just has like over here for this part, but the size of the hole is like the size of the hole cannot be too big, whereas that's where we bring this in. So what's the size of the hole? For diffusion, it's like the size of the hole must be bigger. So the diameter because there may be one or more holes, so yeah. So the diameter of holes are longer than the mean free path of the molecules. So if you're going to question about like what's the mean free path of the molecules, if you're going to roughly just explain it, it's like before each collision, the average of the length between two collisions, okay? So, but if you want to specify on it, we'll explain it on future lessons. So, well, for effusion, the diameter of holes, so there cannot be too many holes. Well, let me just also tell that the diameters of holes are shorter than the mean free path like this, okay? So over here for this part, it must be shorter than the mean free path of the molecules, so that this will actually it will be effusion, okay? Well, for the rate over here, the rate of diffusion is most definitely slower than effusion. Well, effusion, it is faster. The rate is, so over here for this rate, just to say it bluntly, it is basically speed or velocity, okay? faster than whoops. Okay, so this part over here, the rate of is, you can just call it speed if you want. Well, over here for this part, well, let's see difficulty. So it's basically difficulty of how like this moves to the other side or just moves, travels. The difficulty of the molecules traveling. Well, for the difficulty for diffusion, it is easy because that over here, even though it may be slower, but it's going to be easily. It can travel more easily because that there's like more free space and all. While for infusion, it's going to be difficult because that even though it can travel faster, it is going to be harder to have these molecules to travel to out of the small hole. Okay, so the tiny hole is going to be harder to travel through. Okay, well, let's see for accuracy. So the accuracy, as I told you, it will definitely, so you can see that this part afterwards it will be spread out, but definitely not evenly, because that for this part, when this travels to the other side, it may be traveling to the other side, but it collides at random, so the travel, it would not be spread out evenly, because that even if they travel to the place with lower concentration, it is still going to be at random. So this is only approximately accurate. Okay, so for this part over here, it's like generally speaking, they spread it out equally, but they didn't actually spread out equally, okay, evenly. Well, for effusion, it is accurate. Because for this part, when the gas just escapes through the tiny hole, is that it is definitely accurate that how when it escapes, especially it travels through the holes. Okay, so over here for this part, so for her accuracy is that for effusion it is accurate, while for diffusion is approximately accurate, but definitely not completely accurate. Okay, well, for the conditions is that for diffusion and effusion, for diffusion is that there must be one place it's basically that there's definitely a place with a higher concentration than others. Or you can say lower. Both are the same anyways. It's like if they are already spread out evenly, then the diffusion wouldn't actually happen and they wouldn't be mixing together. It's like there must be a place with higher concentration. While for this effusion is that there must be here a place with more pressure, so that has the more pressure, so that the gas can escape through the tiny hole. Okay, so there must be a place with more pressure. like normally for effusion they do it to a vacuum, but if there's like no but if there is like no vacuum, if you can't do it to a vacuum, then they'll just do it to like normal air and all. Okay. Well, for examples of diffusion, it can be the fragrance. So for the example, there can be a lot of examples. So for the examples over here, okay, so over here the fragrance of the flowers, hers is like, okay, so over here if you're talking about at the same place, then no, it will not work. So right just at the backyard. Can be smelled. In the living room. Well, this over here is more or less obvious because that for this part, the fragrance of the flowers, because it gets mixed with the air around us that we breathe in, and without having any like chemical reaction of some sort. Okay, so it's like it can be anything. It can be from cooking food, the smell of the food. It can be someone cutting grass. You can smell it. Then or your flowers growing near your house and all. You can smell it. It's like diffusion. It can be with any type of gas. Okay, it doesn't. It's just that when you have like the fragrance and all, it just can make it more obvious, but it doesn't actually matter what kind of gas. Okay. Well, for effusion, you can say that there's a gas leakage. Okay, so over here for this part, had from for these it's like, well, let me just explain to you roughly again, like for this part. So definition and meaning. Definition is like the process, or the meaning is what it actually is, like what it expresses and all, while the size of the holes is like the what the conditions, like what the size of the holes must be for these either of these to happen, while the rate is that which one is faster, which one is slow, basically the speed, while the difficulty is the difficulties of the molecules just passing through, while the accuracy is by the Graham's law. You can show it, like how accurate these are. So if you want to know more about the Graham's law in the future, you can also listen to future videos talking about both the Graham's law and the free path. So first free path, then second Graham's law. Well, for the conditions, it's basically here what must be there, like other than size of holes. holes is like what's so important for diffusion and effusion to happen, because that for diffusion there is no place with higher concentration or someone with higher density and all, then diffusion would not happen. And if both sides of pressure are the same, diffusion would not happen. Okay, while over here for this part, the conditions, then the next examples, you can just take any examples. It's just that the example that I chose here is more obvious because you can smell it and all, but for any gas it applies to it. While for effusion, is that a gas leaking, you can say that in your pipe you have a gas leak in your pipe and it's very small. So yeah, effusion happens, and then after that it can be any sort of tiny hole and all. So that will be all for this lesson. Last but not least, thank you for your watching.